Okay, I'm going to work a few problems from section 9.5 with you guys, adding and subtracting fractions. So, or I should say, it's actually, what is it called? Addition, subtraction, and complex fractions. That's what it's called. Okay. But these are rational numbers, basically. The problem is that they just have polynomials in them. So you want to follow addition or subtraction rules of fractions. However, it's a little bit more complicated. So when we're adding and subtracting fractions, we always need common denominators. Problem is here, our denominators are polynomials. These polynomials can be factored. So that's the first thing I'm going to do, because once I can factor them, then I know what the least common multiple of the two denominators would be, or what basically the least common denominator would be. Okay, so let me get my pencil. Good here. Okay, so for this first one, I'm going to leave my numerator. I'm going to factor my denominator. Now that's a perfect square trinomial. So this is x plus 4 times x plus 4. This one over here, leave my numerator alone, factor the denominator. That's a difference of two squares. So I'm going to go x plus 4 and then x minus 4. So when I look at my denominators, I can see that I have two x plus 4s here. Well, I only have one there, so this one's going to need another x plus 4. And then over here, I don't have an x minus 4. I have an x minus 4 here, though. So this one's going to need an x minus 4. So what I'm going to do is I'm going to multiply over here, top and bottom, an x minus 4. And then over here, I'm missing an x plus 4, so top and bottom get multiplied by x plus 4. Okay, so distributing my top, I'm going to end up with 2x squared minus 8x plus x minus 4. Now, you want to be really careful here. This is a subtraction. Okay, and everything that I'm subtracting from this numerator over here, I want to make sure that I know that every single term is going to get subtracted. So I'm going to put this in parentheses, this numerator. This is going to be 3x, and then still a positive 12. Now, my denominators are exactly the same, so I'm going to rewrite everything over just one of those denominators, which, again, are exactly the same. So I got an x plus 4, an x plus 4, and an x minus 4. So I got two x plus 4s and an x minus 4. Now I'm going to combine like terms, so I'm going to just work on the numerator now. So I'll keep working down. So I have 2x squared. That's a negative 7x. A minus 4. Okay, now this is, again, where it gets tricky. The subtraction, anytime you're subtracting fractions, you want to be really, really careful. Or subtracting polynomials, that subtraction sign has to get distributed. So if I distribute that, I get a negative 3x and a negative 12. Again, all over my same denominator. We'll just leave that alone for right now. I'm going to continue working on simplifying my numerator. So again, I have a 2x squared. We'll go negative 10x. I was just making sure I did that right. Minus 16. And here I've got an x plus 4 squared, x minus 4. Okay, numerator is completely simplified. So the only other thing I can think of doing here is maybe I can factor the numerator so that one of these factors, or a couple of them, might reduce out. So I'm going to keep simplifying and factoring. So I see that in the numerator, these three terms have a common factor of 2. So I'm going to factor that out to begin with. And then keep my denominator. Now from there, I'm going to look for factors of 8 that potentially will give me 5. So factors of 8 are like 2 and 4 and 8 and 1. Anyway, I can add any of these or subtract them to get 5. I don't think so. So I think there's no more factoring that can be done. Let me look here in the textbook. That's exactly the answer that the textbook is giving us. So no more factoring can be done. Had I been able to factor this maybe and get an x minus 4 out of it, then I could have reduced with something in the denominator. But this right here is my answer. Okay, don't be afraid to take up a lot of space. Okay, these problems can get really complicated if you're not following your work. So you want to show all your work, you want to show all your steps, so that way you can actually follow your work logically. All right, the next one I'm going to do is number 37. I'm going to go ahead and just turn my paper over. So now I'm adding. Again, same rules apply as when you're adding any fractions. These just happen to be fractions with polynomials in them. So I need common denominators. So before I can do that, I have to factor my denominators and see what the actual factors are. Because only once I know what the factors are can I then find my least common denominator. All right, so my first one seems to be the only one that can actually be factored. These cannot be factored. So this is really going to have, let's see, 10x will stay the same. And the denominator I can factor out of 3. And I'm left with x squared minus 1. Which really, I'm not going to write the rest of that. Okay, we can just say plus and then, okay. This now is a difference of 2 squares. So I can factor that even further. So this is 10x over 3 times x plus 1 times x minus 1. Now I'll write the rest of it. So plus 4 over x minus 1 plus 5 over 6x. Okay, so let's see here. Trying to find my least common denominator. Well, I know that basically they need to have an x plus 1 and an x minus 1. However, they also need to have, well, 3 times 2 would give me 6, and this one has a 6. So I think it's going to have a 6. So I'll just write it over here what I'm thinking our least common denominator is going to be. It's going to be x plus 1, x minus 1, for sure. Okay, which takes care of both of these and that guy. And then it's going to also have a 6, because 6 can't be turned into 3 without dividing, and then you're going to end up with fractions everywhere. So it's better to go bigger. So we'll make this 3 into a 6, and we're also going to need an x. So I think my common denominator is going to look like that. So to get that common denominator, this one is just missing a 2x. So I'm going to have to multiply top and bottom here by 2x. This one already has the x minus 1, so I need to multiply by the 6x and the x plus 1, top and bottom. And then this one has the 6x, but it needs basically this is x squared minus 1, or x plus 1, x minus 1. I'll put x squared minus 1. Ooh, maybe that's not a good idea. How about in the denominator, I'll leave it as x plus 1, x minus 1, so that they all look the same. I like to keep my denominators factored. My numerators are what I'm going to simplify. So I'm going to multiply it all out. I'm going to get it all together into a polynomial and then see if I can factor that numerator and maybe reduce with something in the denominator. Which is why I said to myself, this is a sum and difference pattern. I know that then it becomes a difference of 2 squares. Or back here, it was a difference of 2 squares, and I factored it into a sum and difference pattern. All right, so this gives me now 20x squared. Now, my numerators right now are what I'm going to go through and actually multiply out. My denominator, I know, for all of them, is going to be this right here. So I'm just going to write one denominator. Okay, so going through now, this gives me a 24x, x plus 1, and then this will give me a 5x squared minus 5. I don't like to skip too many steps, because if I do, I usually end up messing up. So, continuing to work on my numerator, I've got a 20x squared plus a 24x squared plus a 24x plus a 5x squared minus 5. Denominator staying the same. Continuing to simplify that numerator. I guess 44x squared. Oh, 49, right? I've got this one, and this one. So 49x squared plus 24x minus 5. All over, and then I've got that 6x, and the x plus 1, and the x minus 1. So the only thing left to do at this point is to see if I can factor the numerator into any of these factors and see if they'll reduce. So I'm going to look for factors of 49 and factors of 5 that potentially will add or subtract to give me 24. And actually they would have to subtract because that's a negative, so the two signs would have to be opposite. So I've got 7 and 7, or 49 and 1, and I've also got 5 and 1. So I can see that I could get like 35 and 7. Okay, so 35 and 7. So I can add these two together and get 42. I could subtract them and get 28. So I don't think that that's going to work. And then 49 and 5. So I could subtract them and get 44. Add them and get 50. Did I do that right? Yeah, 54. So I don't think that that's going to work either because I need a middle term of 24. So this can't be factored. So let me see what our answer is. This is exactly how the answer is given in the text. Okay, so there's our answer. All right, I'm going to do one more with you guys, and that is number 45. Which is a complex fraction, or you'll be doing some cons later on that are, they'll call these nested fractions, where you have fractions within fractions. All right, so 45. 1 over x cubed plus 64 divided by 5 over x squared minus 16 minus 2 over 3x squared plus 12x. All right, so what I'm going to do here, I'm going to deal with my top fraction and my bottom fractions first. So I can see in my bottom fraction, I've got two terms, two fractions that need to be subtracted. So I'm going to try and combine these into one fraction first. Then I can take my numerator and my denominator, divide them. Okay, and we'll get to that in a minute. But let's deal with one thing at a time. So the first thing I'm going to deal with is just my denominator. So I'm going to leave my numerator alone in this complex fraction. Now my denominators, the denominators of my denominators, I can see are not the same. So I'm going to have to factor these, and I'm going to have to figure out what's my least common denominator, and then I can combine them into one fraction. So the first thing I'm going to do is factor them. So this is a difference of two squares. So it's x plus 4, x minus 4. This has a common factor of 3x, so I'm going to pull that out, 3x, which leaves me with x plus 4. So if I'm looking for my least common multiple, or my least common denominator, I can see that x plus 4 is definitely going to be one of them. I'm going to need an x minus 4, and I'm going to need a 3x. Okay, so coming down here. Actually, let me go here. So this one needs a 3x, so I'll multiply top and bottom by 3x. This one needs an x minus 4, so I'm going to multiply top and bottom by x minus 4. Okay, so leaving my numerator alone right now. We'll get to that, I promise. This one's going to give me, now this is 15x. And be careful here. So this is a minus 2 times that junk. I'm going to write it out. Minus 2 times the x minus 4. All over my common denominator, which ended up giving me 3x times x plus 4 times x minus 4. Now going on and simplifying the numerator of the denominator. I know that's confusing, but simplifying the numerator of the bottom fraction. Okay, so this is a 15x, and then distributing that negative 2 gives me a negative 2x and a positive 8, all over 3x times x plus 4 times x minus 4. And we are getting somewhere, I promise. I'm just going to simplify this numerator now. So keeping the numerator that we haven't even been touching yet, we'll get to that, I promise. I now look like I have 13x plus 8, and then 3x times x plus 4, x minus 4. Okay, so now I've got a nested fraction, but this is good. Right now I've got a fraction, this fraction on top, divided by a fraction. And remember, we don't divide fractions, we multiply by the reciprocal. So really, instead of having it written this way, I'm going to turn this into a multiplication problem, where I now multiply by the reciprocal of the denominator. Okay, so I have 1 over x cubed plus 64 times the reciprocal of the denominator, which is 3x times x plus 4 times x minus 4, all over 13x plus 8. Now, probably a lot of you guys don't remember this, but this is a special factoring friend. This is a sum of 2 cubes. So, a sum of 2 cubes, let's see. And I know it's a sum of 2 cubes because I know that this is really x cubed, so I got something cubed, plus, and then this is 4 cubed. Now, if you don't have me around, you should have your factoring friends around, and you did add these to your factoring friends. So just as a quick reminder, I went back, because I don't have all of my friends with me, I went back onto the 6.4 factoring and solving polynomial equations. This was one of our lessons that we did, and some of our factoring friends here were that we had some more factoring friends, and one of them was the sum of 2 cubes. So anytime you have something cubed plus something cubed, this is how you break it down. And the goal is to figure out what A and B are. And then once you have A and B, so in our situation, well, I'll talk about that in a minute. Once you have that, then you just follow this very simple pattern. It's the same. Let's see, can I? Do we do a difference of 2 cubes? There's the sum. Oh yeah, here we go. So difference of 2 cubes looks very similar. The only difference is, so for a sum of 2 cubes, your subtraction sign is here. And in difference of 2 cubes, your subtraction sign is here. Otherwise, the patterns are exactly the same. Okay, so I'm going to leave this behind and move back to my screen here. That was probably pretty choppy. Sorry about that. Okay, so basically what we've just learned is that you have, anytime you have a sum of 2 cubes, like that, you're basically going to break that down into a plus b, and then a squared minus ab plus b squared. Well, in this scenario, my a is x and my b is 4. So now when I'm factoring this, I just follow this pattern, a being x, b being 4. So I'm going to go ahead and factor this denominator in my first fraction. So I'm going to have, let's see, x plus 4, x squared minus 4x plus 16 times, and then this was a 3x times x plus 4, x minus 4. Now I can think about factors of 16 that might be able to give me 4. in order to factor this a little bit more. I'm not sure that there are any. So 4 times 4, or 8 times 2, or 16 times 1. I don't think that I can add or subtract any of these to get myself 4. So I think this is as factored as it's going to get. But I do see one factor that I can reduce, which is this x plus 4. So the x plus 4 in the denominator here will reduce with the x plus 4 in the numerator there, leaving me with what I think to be 3x times x minus 4 all over x squared minus 4x plus 16 and times that denominator, which is 3x plus 8. Because we're multiplying here, we don't actually need common denominators. We're just multiplying. So let's see, where is the answer? 45, okay. And we got it. Good job.